Hello everyone, welcome to the another Google Cloud Lab session called text classification using reusable embeddings. So without any delay, let's start the lab. And in this lab, we are going to complete the tasks provided in this lab. So there won't be any technical or theoretical discussions. We won't be discussing any. So without any delay, let me launch. Let me enter the password. Okay, agree. Okay, now you can pause the video and go through the overview and the learning objectives. The overview is to recognize the source, whether it is from GitHub, TechCrunch, or New York Times. So we'll be using a pre-trained TF hub. Okay, these are the two objectives in this learning objective. Setup, just now I completed, so looking good. So let's enable the AI library. Let's search AI platform training and prediction API. Let me open enable. Let it enable first. Looking good. Then we'll navigate to search box, the library. Here we'll enable Vertex AI API. Vertex AI API. This is also enabled. We will be able to see this. So now let's start with the task one. Let's go to the cloud storage and create a bucket. Let me create a bucket. For this, let me use the project ID itself for the uniqueness. So get the unique name for the bucket and click on create. I will leave as is. I will expose to public. That should be fine. Okay, now let for the task two, go to Vertex AI Workbench. User manager notebooks. There is something is going on. Cloud learning service. I don't know about this, but let's say user manager. Let me create new. In this, I will name the notebook as for this. Let me check whether which version is that. This is having NumPy, SciPy, Scikit. Going back, I will change this to lab workbench in US zone, US West Bay zone, and I will select 2.14 because my previous experience 2.11 is not working for me. So I'm selecting 2.14. But here in the lab, they're asking us to select 2.6. So we don't see TensorFlow Enterprise 2.6 here. So I'm using 2.14. And rest all, I will leave it as default and select create. So it will take a couple of minutes to get created. We'll wait for it to get created. I will wait for Open Jupyter Lab to open. Now the lab is ready. So it took about 2 to 3 minutes. So let me open the lab menu and move on to task 3. Clone the repository within Vertex Lab. Let me open the terminal. Paste the code. On this. This will take a few seconds. Once the repository is cloned, move on to task 2. Okay, and let's navigate to this file. Training data analyst, courses, machine learning, deep dive 2, text classification, labs, reusable embeddings. Let me open the file. For the interest of the time, I will open the solutions as well. So the solution is available in this specific location. Going back folder, opening solutions, and opening reusable embeddings. Opening the labs folder again for any basic plan. Let me close the terminal, and we have 2 files here. You can see the first file is the lab, second file is the solution. Let's minimize this, touch space. Okay, so without any delay, let's get start. And you can pause the video or you can clone the repository and go to the file for reading all these purposes. Okay, so my intention in this discussion is to execute the code that is provided for us. So let me import my that. Before importing, let me go to the edit, clear all outputs. Now it's using importing OS. BigQuery extension is already loaded. We use it. Okay. Replace the project with the question is can replace the project heading. I'm not sure whether they're asking for project name or project ID. Project is provided and the region is central one, but my region is the US West. Let me check this too. West one. Where my workbench, my cloud. Let's see where is my cloud storage. This is multi-region. Okay, let me go. So that should be fine. So let me change back to central. Okay. Only project ID I have provided. So let me shift enter. Configuration is done. After new settings will be query public set. Then click and see where the file is decided. here you can see. So let's get into combines headlines in October 2006 until 2002. Here is the sample data set. So let's select the query we have downloaded, and this is the sample data set. So URL, title, and score on the article. Uh, let's see this information. So this is the article. So what we are trying to do is like the URL, I want to be left with NY times. Okay. So we are using some regular expressions, and you can see the select query from data hacker news.com in the regular expressions .com and length titles by source. Okay. Downloading, you can see all that github.com, medium.com, youtube.com, ytimes.com, blogspot.com. So all these are all .com values. Okay. Now we have good parsing URL to get the source. Let's put together the data set of the source and titles. This will be our labeled data set for machine learning. Okay. Let me execute this script. For ML training, we usually need to split our data into training, yeah, and evaluation. We all know that. So now we have the BigQuery client, project, and data frame. So let's see what's the title data set looks like. Okay, title, source. The full data set contains 311,000 titles. Here number labels. Let's see how many labels. GitHub is having this match. And my times TechCrunch. So I think at this point, we'll create a data folder here. So this will create a data folder here, and full data is titles full.csv, and join, and we'll do some mapping, and then create a file over here. Let's sample 1,000 articles from, and make sure we have enough examples to each label in our sample data set. Let's sample it. Yeah, 550, 542, 257, and 201. So samples are good. Sample data set to yes. Title sample. Okay. You can see sample CSV and title CSV. Okay. Now let's import the necessary TensorFlow and its versions. So let's wait for the TensorFlow version to be printed. We execute matplotlib and an inline, and model directory text models directory will get created. Not yet. There are two files, title full of CSV and title sample of CSV. Now we have the dataset name, sample path, the headings, heading book, and as well as the source of values. This also looks, it will have about 311K. Now we are defining the classes. Now one hot categorical. Okay. encoding labels. Labels. Preparing the train test. So 95% of the titles will be in the training set. You can see this here. Next value count, course count. So 95% is given to training and test. Features and labels. So this is what uh, features or labels are created, and you can see the trainings, X train and Y train. So these are all the encoded labels. Okay. So next, lab 1A. Now here we need to do a keras layer. To our solutions. So till now we have data has been loaded and we're using the now if you see this is the TensorFlow hub to the pre-trained model. 50-dimensional vector and pass it to a center. So this is having a 50-dimensional vector. Now let's see. Now 50-dimensional vector has been created. Civil model. Let's run this. Same constant. Use this text. Now you can see in Spherical model only 20 parameters has been provided. The shape. Show you the shape as well. Here you can see the shape is 20, whereas here in the provided we have a shape of 50. Similarly, now let's see the task C. Now we have 20 models, 20 shape. So you can pause the video and go through what you needed. So here we are building a model, sequential model of module dense 16 activation is the value and in classes activation is softmax and game. This is the definition. Let me run this definition. And there is a batch size. So this is how we train and evaluate the parameters. How do we train? How we train and why train? What is the model directory? So now let's have the data, validation data, model. So that is 50 epochs. Here you can see 50 epochs as 25. So it is going to take 2 epochs times. So once this is done, let's plot it. So I'll pause the video and I will come back once this is all this epochs has been completed. So all 50 epochs has been completed and now you can see it took around about 25 to 30 minutes. You can see an average of 30 seconds of each epoch for 50 epochs. And you can see the loss over here. There is a reduction. Basically, the loss will come reduced to 0.07 and accuracy has been increased. you can see the numbers. Let's plot it so that it will be easier for us to see. Now you can see loss and value loss. Loss has become reduced and value loss has been little bit. The accuracy has been increased. So now let's build a model for swivel model. And okay, 50 epochs. Let's see how fast. Now you can see the fastness, how the training has been increased. And you can see the loss getting reduced, accuracy has become increased. But achieves lower validation accuracy. Now you can see swivel trains faster but and requires more epochs to train on. So I will let it run for another few seconds. Now let's see the plot. Well, okay, this is also looking good, but you can see there will be a achieves lower validation accuracy and requires more efforts to train on. Well, if we use swivel. Okay, this concludes our training this lab session. So thanks for joining and have a great day.